Hey guys, welcome back. Today's lesson is going to be a quiz review just to help you get ready for the quiz on fair division. This will be the first quiz that we've had on some of these fair division topics, so I want to make sure you get a good review day and hopefully we all do well on this quiz tomorrow. All right, so here in example one, we're going right back to the beginning. One of the first examples of fair division that I showed you guys was splitting a pizza between you and another friend. All right, so we've got Lucas and Jacqueline here, and they buy a pizza for $10 that is half pepperoni and half veggie. All right, and they cut the pizza into 8 slices. So here I've got a circle representing my pizza, so I'm going to go ahead and cut this thing into 8 slices, just like it says in the problem. And you may or may not need to do this, and it's okay if you don't do it, but some people really like having just a visual aid to help them think about how this division goes. And I know it helps me. I'm very much a visual person. Okay, so the pizza is cut into 8 slices, and let's say this is the pepperoni slices, right? Because it's half pepperoni, half veggie. Right, so these are all my veggie slices over here. And the total value of the pizza is $10, right? So all the slices combined are going to be worth $10, and that's going to be true for both Lucas and Jacqueline. It doesn't really matter since they paid $10 for the pizza. Now it says Lucas likes veggie 4 times as much as pepperoni, right? So Lucas very much values the veggie pizzas much more than the pepperoni pizzas. So the way that we figure out like the actual value for a slice of pizza is to use a little bit of algebra. So I'm going to assign the variable x, right? So we're going to say that a pepperoni slice is worth X dollars, which means every pepperoni slice would have to be worth X dollars. And since Lucas likes pepperoni 4 times, or likes veggie 4 times as much as pepperoni, a veggie slice would be 4X dollars, which means every subsequent piece of veggie pizza is also worth 4X dollars. Okay, now when I add up all of these pieces of pizza, they have to equal $10. So this gives us a nice convenient equation to work with, right? So I have 1, 2, 3, 4. So 4 times 4x is 16x. And then 1, 2, 3, 4. So there's 4 more x's. And this has to equal $10. Okay. Combine like terms a little bit. So we got 20x equals 10. And then solve for x, we can divide by 20 on both sides. The 20's cancel and we get x equals 0.5. Now remember, x represents the cost of one pepperoni pizza, or one pepperoni slice. So a pepperoni slice is 50 cents. Okay, which means if Lucas values the veggie pizza 4 times as much, a veggie slice is going to be worth $2. Right? So now we know what a slice of pepperoni is worth. We know what a slice of veggie is worth. And then it asks us, what is the value of a slice that is half pepperoni and half veggie? And this, when most of you guys did well on this example on the previous quiz when we did this, but when it did ask for a slice that was half of pepperoni, half of veggie, there was some struggle. So I made sure to pick an example where this happened. And I want to show you what they're talking about here. So if this confused you, hopefully this will clear it up. So a slice that is half pepperoni and half veggie would be a slice like this. All right, so here's your slice of pizza that you're trying to find the value of. Okay, so there's our pizza, and it's half pepperoni, half veggie. Okay, so this half of the pepperoni slice is worth 25 cents. And then this half of the veggie slice right here is worth $1. Right, so if I add those two together, we get a grand total of $1.25 for a slice that is half pepperoni, half veggie. Okay, so this is the number that they are looking for. This is the slice of pizza that they're referring to in that problem. All right, guys, hope you found that helpful. That's really all there is to that problem. A little bit of algebra, a little bit of thinking about what they're asking for. You might get lucky and they might just say, what's the value of a slice of pepperoni, or what's the value of a slice of veggie pizza, in which case you'll have that done here. But if they give you one of these half and half deals, you got to make sure that you split each one in half and add them together. Okay, let's look at example 2. So this is another one where we kind of go back to the beginning and we talk about just simple fair share type things. All right. So there's this big bag of candy. Josh, Dakota, and Chad, they split the candy into 3 bowls, and they each go through and look at each bowl and they assign values to those bowls. All right, and all of them have different value systems, so they're not going to agree on what the value of bowl 1 is or bowl 2. They're all going to have different values for each bowl. They even have different values for the bag of candy in general. Okay, so we're just going to start by determining what is the fair share for each person. Right, so fair shares, and we'll start with Josh. All right, so Josh thought the whole bag of candy was worth $7. All right, so we take that $7, and since there's 3 people, Josh would feel like he is entitled to 1/3 of that bag, right? So we would take $7 divided by 3, and that value becomes $2.33. Okay, so Josh is only going to be happy if he receives a bowl that is worth more than $2.33. Then we repeat the process for Dakota. Right, but Dakota's value changes. It's not the same as Josh's. Dakota values the entire bag at $4, but he's still only entitled to 1/3 of that bag. So $4 divided by 3 would be $1.33. So Dakota is only going to be happy if the bowl that he receives is worth more than $1.33. All right, then we do the same thing for Chad. Chad's value of the bag was $5, so we would again divide that by 3, and Chad's fair share becomes $1.67. He would only be happy with a bowl worth more than $1.67. So then we can come over here and we can actually say what bowls they would be happy with. Okay, so if I look at the 3 bowls here, the only one that's worth more than $2.33 for Josh is bowl 1. So Josh would only be happy with bowl 1. Now Dakota, I go through Dakota's values here. There's only one bowl that is worth more than $1.33, and that is bowl 2. So that is the only bowl that Dakota would be happy with. And then Chad, the only bowl that he would be happy with is bowl 3. That is the only one worth more than $1.67. Okay, so these would be what we call declarations. And we're going to come back to these later, but we determine fair shares and we even determine declarations for some of our division processes. Okay. All right. Let's try another one. So this was one of our official division methods called divider chooser. Let me pick a different color here. I'm going to go green, like green. All right. So we're looking at divider chooser. And if you recall, the way that the divider chooser method works, it's the you cut, I choose method. So one person is the divider. They're going to take whatever it is you're dividing and they're going to cut it in half. All right, so no matter what they do, however they cut it, they would value each of the 2 pieces they create as equal. All right, that they would be okay with receiving either half that they create. All right, so once that person makes the cut, the other person gets to choose the piece that they feel is worth more. All right, so let's pretend that we're doing this. We have a fun size bag of candy that's got 100 Snickers, 100 Milky Ways, and 100 Reese's, and they give us Damien's value system here at $3, $5, and $4. All right, so just recall, all right, so if Damien values 100 Snickers at $3, then the 100 Snickers together, that should be a 3. Then each individual Snicker is worth 3 cents. Okay, so then the Milky Ways would be worth 5 cents and the Reese's would be worth 4 cents. All right, so now Rachel is going to be the divider. So she's going to go through the candy and she is going to split it up. And in one half, she puts 20 Snickers, 55 Milky Ways, and 55 Reese's in one half. Okay, we want to figure out what that half is worth and then deduce what the second half is going to be worth. All right, so let's start with this one. So remember, Snickers were worth 3 cents a piece, right? We figured that out right at the beginning. According to Damien, right, the total value of all the candy was $12. And that just came from adding these up, right? So all of the Snickers, all the Milky Ways, and all of the Reese's, 3, 5, and 4. So if I add those up, the entire bag of candy is worth $12. And since there's 2 people in the division, Damien's fair share is going to be $6. Right, that would be half of the bag. Okay, So now we're going to figure out the value of the 20 Snickers that Rachel put in this half. Okay, so 20 Snickers at 3 cents a piece is 60 cents. The value of the Milky Ways, so we would do 35 times 0.05, and I'll do that on my calculator here. It'll turn on, there we go. All right, so we would take 35 times 0.05, and we get a value of $1.75. And then the 55 Reese's, right, so if I do 55, and remember the Reese's were worth 4 cents a piece, so that's going to have a total value of $2.20. So in this division, there are 20 Snickers, 35 Milky Ways, and 55 Reese's, and I have the value of the 20 Snickers, the 35 Milky Ways, and the 55 Reese's. So that entire division is going to be worth, if I add that up, I get $4.55. So if I'm thinking about that, since I know Damien's fair share is $6, I know that Damien's not going to be happy with this half. There's no way he would choose this one. So we need to see what half 2 is worth, so we know that Damien is going to be happy with whatever half he chooses. Okay. Now remember, in the entire bag of candy, there were 100 Snickers, so if Rachel put 20 in this half, that means the other half contains 80 Snickers. If there were 35 Milky Ways in this half, well, then there would have to be 65 Milky Ways in the other half. And then if there's 55 Reese's in the first half, there would have to be 45 Reese's in the second half. And then I can go through the same process of figuring out the values of each of these. All right, so if I did 80 Snickers at 3 cents a piece, there's $2.40 worth of Snickers in half 2. And you might notice that if I add the value of Snickers in the first half and the value of Snickers in the second half, it gives you a grand total of $3, which is what we were supposed to have. Okay, so now if I do the Milky Ways, it'll be 65 Milky Ways, and those are valued at 5 cents a piece. So we have 65 times 0.04, or 0.05, which is a grand total of $3.25. So there are $3.25 worth of Milky Ways in half 2. And again, if I add up these two values from both halves, we get a grand total of $5, which is exactly what we wanted. Right, now last step here is just to do the Reese's. We had 45 Reese's at 4 cents a piece, for a grand total of $1.80. And again, if you add those up, you'll get $4. All right, so you see your 3, 5, and 4 that we started the problem with. Now all I have to do to figure out the value of half 2 is add the three values together. So $2.40 plus $3.25 plus $1.80 is $7.45 worth of candy. So in Damien's eyes, there's $4.55 worth of candy in half 1, $7.45 worth of candy in half 2, so logically Damien would pick half 2. All right, last example here that I'm going to show you. We have Hillary, Carissa, Mackenzie, and Jacqueline, and they are dividing a piece of land using the lone divider method. Okay, so this is a different method than divider chooser. This method is nice because it allows us to do a division with more than 2 people, and it actually builds off of the divider chooser method. So the way that lone divider works is one person is selected to be the divider. You should be able to look at the table and determine right away who the divider is. So remember, the divider is always going to chop up the pieces of land so that each piece is equal. So we can instantly tell that Jacqueline is the divider. Because if I look at her values, they're each the same, right? 25, 25, 25, 25. The only person who would do that is the divider themselves. Okay. So we're going to go through and we're going to start with our declarations here. Okay, so we have Hillary, Carissa, Mackenzie, and Jacqueline. Okay. And all declarations are, so in this first phase here, all they're doing is they're just stating, I would be okay with these pieces of land. How do we know that they're going to be okay with a particular piece of land? If that particular piece of land is worth more than their fair share, they'll be okay with it. So everyone's fair share, since they did this in percentages, is going to be 25%. Okay, and the way that we figure that out is based on the number of people involved in the division. If I take 100% of the land and I divide it equally amongst 4 people, you should get 25%. That is what each person is entitled to. So anything greater than 25%, they would be happy with. So let's go to Hillary. All right, if I look across Hillary's evaluations here, so she looked at each piece of land and she gave it a value. So she thought piece 1 was 27% of the total, piece 2 was 20%, piece 3 was 20%, and piece 4 was 33%. So she would be okay with piece 1 and piece 4. She would be happy with either one of those. Then we go to Carissa and we do the same thing. So Carissa would be happy with piece 1 and then piece 3. Piece 2 and piece 4 are below 25%, so she would not be happy with those. Then we go to Mackenzie, and Mackenzie, the only piece that Mackenzie would be happy with is the 39%, right? So piece 4. And since Jacqueline was the divider, Jacqueline's going to be okay with any piece. Now, once we have done the declarations, we go and we look to see if there is an easy way to give each person a piece of land that they would be happy with. Okay, so I'm just going to abbreviate names here. And we'll see if we can come up with a happy division. So I always like to start with the most picky person. The pickiest person is the one that was okay with the least number or the least pieces of land. So I look at Mackenzie here. She was only okay with the one piece of land. She was only okay with piece 4. So I'm automatically going to give Mackenzie piece 4 because there's no other way to make her happy. Piece 4 is now no longer available to any other players. So then the next most pickiest person is going to be Hillary, because now Hillary is only going to be happy with piece 1. There's no other piece that will make Hillary happy. So I'm going to automatically give piece 1 to Hillary. And now piece 1 is no longer available to any other player. So now when I look at Carissa, Carissa would only be happy with piece 3, so I'm going to give piece 3 to Carissa. Now piece 3 is gone. The only piece remaining is piece 2, and Jacqueline would be okay with piece 2 because she would be okay with any piece. Jacqueline was the divider. So this would be the settlement. So Hillary would end up with piece 1, Carissa would end up with piece 3, Mackenzie would end up with piece 4, and Jacqueline would end up with piece 2. Now, if there was no way to do a happy division, recall that the rest of the lone divider method said to take one of the pieces that no one cared about or that no one liked, give it to the divider, send the divider on their way and say, have a nice day. And then the other 3, put the remaining pieces back together into one big piece and elect a new divider. They would then have that person divide up, reevaluate, redo their declarations, and start the process over. All right, guys, that's it for review today. I know I didn't do any of the estate division problems, but that's because we've been doing examples for the last 4 days in a row. So if you need to review those or practice those more, make sure you check out some of the earlier videos and some of the earlier practice sets to get more practice with that. All right, guys, have a great day.